Okay, welcome to Chapter 4. Chapter 4 is about something called moments. Now, everything that we have done so far has centred it upon our objects being what we call particles. This is that we don't consider any length of the object, we just consider that they're a little dot and we look at how forces act on them in different directions. Well, that all changes when we do moments, because instead of our objects being particles, we're mainly going to deal with objects being rods. So a rod is still a one-dimensional object, right? It's not a two-dimensional shape, it's one-dimensional, it's a straight line, and lots of things can be done with rods, right? So here I've got a nice example of a rod. This is actually an incense stick. And I'm going to use it to demonstrate what we can do with moments. So the big difference with when you've got a rod, a long shape, is that you can rotate it, right? So if we see, I can push this up, okay, and we can push it down, and it's going to rotate, it's going to turn around. So we can see I can push it, if I push it up here, this is moving in an anti-clockwise direction, and if I push it down, it's moving in a clockwise direction. Right? You'll notice I've got my finger on, that's creating a pivot point. So the pivot is the fixed part of the object. If we have a pivot point in the middle, we can see the same thing can happen, right? So I can move it, if I move this bit, if I apply a force here, it'll move, that's moving anti-clockwise, and this will move clockwise. But I can also, using the same pivot, apply a force on this side. So this is moving clockwise, right? No, sorry, this is moving anti-clockwise, which agrees with the force pushing it up there. So pushing it up on this side is the same as pushing it down on this side, right? And then vice versa. If I push up here, we then move clockwise, and then if we push down here, we also move clockwise. So that's what it's all going to be all about. It's all about turning forces and which way we're turning it and how the mathematics of that works. Now, one of the key points with moments, right, is that the force, when we're thinking of acting it, of turning, we always think of it as a perpendicular force. So it's how far up we're turning it, and when we're turning it up, we're thinking of the force acting in a perpendicular direction, right, to the actual rod itself. That's what creates the turn, right? For the rod to turn, I need to have a vertical force here to make it turn upwards. And then it keeps having to be perpendicular to the rod in order for it to keep turning, right? The second thing is how easy it is to turn it. And this is going to be the key point about moments, the key formula that we're going to use all the way through, is that when we turn it, if we apply a force at the end, that will have more of a turning effect than the same force applied close to the pivot point. So if you want to turn a rod like this and you apply the same force here, to get the same turning effect, you would have a much smaller force being applied at the end. So it's easier to turn it if you are a long distance away from the turning point. So that's our first formula, is the turning force, or the moment is turning force, of an object is just the force times the distance from the pivot point. Right, the pivot point is always going to be P. So let's have a look at example 1. So example 1 shows you a object, and it's not the clearest example in the world, right? Here's your pivot point P, and here's your object, which I'm going to colour in blue. So that's the thing that's turning. Now the force is the bit with the arrow, which is going to be the pink bit here. Okay, so the blue bit here is the object, and the pink bit is the force. So if we think what's going to happen in example 1A, right, you've got the turning force is the distance times the force. So the force is 6. So the moment in A, right, is force times distance. So that it's 6, and where the force is acting is here, is 3 meters away from the pivot point. So it's 6 times 3, which is 18, and the units is called Newton meters. Right, because it's how many newtons and how far away, how many meters it is that's acting. And we'll abbreviate this as Nm. For part B, similar setup, let me just colour it in so you can see the blue again. The blue is the object, and the pink is the force. Important not to get confused between the two. So the confusion though in part B is going to be that actually we are not turning we're not turning in a perpendicular direction, right? This angle is not 90 degrees. So all we're going to do is we're going to resolve it in the 90 degree angle. So if this is 35 to this, and we think about resolving it like we've been doing in all the other units, right, you'll see to get the perpendicular, because the moment force is a perpendicular force turning it, we need to resolve it going that way. So we're going from the force of 12 to the dotted line. That's away from the 35 degree angle. So from our work in the other units, we've got the moment is 12, the force, but we've got to multiply by sine of 35 because you've gone away from that 35, times by the distance, which is 8. And you can pop that into your calculator. Sine 35 times 8, and it gives you 55.1 Newton meters to 3 significant figures. Now we're almost done. The only other thing we always have to specify in moments is which direction it's turning. So if we look at this, if we imagine the blue being turned, it's going to be turned that way, it's going to go up. And if you think about this moving here, this is the hands of a clock, this is going anti-clockwise. So it's 18 Newton meters anti-clockwise. And the other one, we're going, that's the pivot point, so this is turning this way, and the blue object is going to move to the left, which is going to move it, if it's pivoting around there, that's with the clock, so this is clockwise.